Okay, this is sample problem 15.1. Carbonyl chloride COCl2, also called phosgene, is a highly poisonous gas that was used on the battlefield of World War I. It is produced by the reaction of carbon monoxide with chlorine gas, CO gas plus Cl2 gas, in equilibrium with COCl2 gas. So in this particular problem, they say the temperature was 74 degrees C, and the equilibrium concentrations of the species involved in the reaction were as follows. So all three concentrations are given. Part A, write the equilibrium expression, then part B, determine the value of the equilibrium constant for this reaction at 74 degrees C. Okay. Just to point out, if you change the temperature, the equilibrium constant may very well change. So that's why they report the temperature. You don't use it in the calculation. So Kc, that's what we use for equilibrium constant, is the concentration of the product. Now there's only one product, COCl2. Remember, we're going to use bracket notation to indicate concentrations. And then we're going to divide that by the concentration of CO. And we're going to multiply that by the concentration of Cl2. Okay? Products divided by reactants. And the exponents are all 1 in this case because the coefficients in the balanced equation are all 1s. Now we can calculate this value. All we got to do is put the numbers in. So the carbonyl chloride, COCl2, it's called phosgene, is 0.1 molar. Okay. Notice I don't put any units in there. The equilibrium constant is unitless, so we just put in the values in molarity, but we don't put the units in. Carbon monoxide is 1.2 times 10 to the minus 2. And then chlorine is 0.054. I'm not sure why they did Cl2 in decimal notation and CO in scientific notation. I'm not sure why the author did that, but they did. So now we can put these numbers in. Just be careful as you go through. Again, check this. Make sure you get the same answer on your calculator. And what I get is 216. I'm going to round it to 2 sig figs, so that would be about 220. Okay. A common mistake when people do equilibrium calculations is because you're dividing by two numbers. It's very common. Someone will type in this divided by this times this, and your calculator would interpret that as 0.14 divided by 1.2 times 10 to the minus 2 times 0.054, and that's not what we have. We're dividing it by 0.054, so make sure that you're dividing by 0.054, and there you go, expression and value.